Flat sawing refers to sawing a flat or horizontal concrete surface, for example, floors, roofs, and bridge decks. Flat sawing is typically done to provide expansion joints, to remove sections of concrete for patching or in controlled demolition, and to trench for plumbing or other below-slab access. Saws for the purpose range from 5 to over 100 horsepower and include walk-behind, self-propelled, and riding models. They may be gasoline, diesel, electric, hydraulic, or air-powered. Blades range from 8 to 54 inches in diameter, and depth of cut may be up to 23 inches with a 54-inch blade. This program covers skills and knowledge necessary for safe, effective flat sawing, including the components of the saw, safety precautions, blade selection and mounting, saw operation, and daily equipment care and maintenance. Saw and blade problems are included in the troubleshooting training module. All flat saws have certain components and characteristics in common. Their frame and undercarriage system rides on 4 wheels. They have an engine or motor to power the saw, infinitely variable speed control for a forward-reverse, and a control to operate a mechanical or hydraulic blade raising, lowering, and depth-setting mechanism. All flat saws are equipped with a blade guard and must not be operated without the blade guard in position. Flat saws typically have a pointer-type alignment device for aligning the saw for cutting, as well as a water supply system to cool the blade as it cuts. It's the responsibility of the saw owner to provide the operator with the proper saw for the job, in safe operating condition, with all guards in place and secure, all fasteners tight, and all controls in proper working order. The owner shall also provide an instruction manual, keep and maintain proper maintenance records, provide a device to measure blade RPM or list the arbor RPM on fixed speed saws, and assure that all operators have and wear proper personal safety and protective equipment for operating the saw. Each operator must fully read and understand the instruction manual for any saw to be operated, and be familiar with all aspects of machine operation, including being familiar with all machine controls and their functions. Any operator must make sure the blade shaft RPM is proper for the size of the blade being used. An operator must not operate any saw that is unsafe and may never leave the machine running unattended. When operating any concrete saw, always wear safety glasses, safety footwear, and hearing and head protection. If conditions warrant, wear a reflective safety vest and proper respirator. Never operate or allow anyone to operate equipment when tired or under stress, or while under the influence of drugs, alcohol, or medications which impair alertness or reaction time. Do not operate equipment while wearing loose-fitting clothing. Always keep hands and clothing away from all moving parts at all times. Do not operate a concrete saw in an area where there is combustible material or fumes. Sparks from the saw could cause an explosion or fire. When hoisting a concrete saw equipped with a lifting frame, always inspect the frame, lifting hardware, and cables before lifting. Now, 2 important safety warnings. First, do not operate gasoline or diesel-powered machines inside a building or other enclosed area. Exhaust contains invisible deadly carbon monoxide. Serious personal injury or death from carbon monoxide poisoning can result. Second, when cutting suspended or above-grade slabs, such as building floors or bridge decks, the workpiece must be supported so as not to fall when cut free. The support must be sufficient to prevent the slab from shifting and falling. Also, when removing the cut piece, proper safe rigging and hardware must be used. Various kinds of diamond or abrasive saw blades may be used on these machines, but you must make sure the blade is of the proper specification and size for the application. Select the right blade and use it properly. Each blade is designed for a particular kind of cutting in a specific range of materials. It's also extremely important that the saw RPM and the blade RPM match, and that the saw RPM never exceeds the blade RPM. If the saw RPM is lower than the recommended blade operating RPM, the bond will act softer, resulting in a possible increase in cutting speed and reduced blade life by pulling diamonds from the bond. If the saw RPM is higher than the recommended blade operating RPM, but below the maximum RPM, the bond will act harder, resulting in more heat at the point of contact, causing the segments to glaze over and stop cutting. Using a blade under these conditions may reduce cutting speed, which may knock the core out of tension, making it impossible to cut straight lines and make the blade pound, causing the core to crack. If a blade is run beyond its maximum rated RPMs, severe damage can occur, including breaking or shattering that could injure or kill the operator or other personnel. Dry cutting diamond blades are available. These are generally used on low horsepower saws and not for continuous sawing. Special controls must be utilized to contain the dust and protect personnel from dust inhalation when dry sawing operations are conducted. If in doubt about the right blade for your application, check the blade specifications or contact the blade manufacturer's representative or website. Most flat sawing is done with wet cutting diamond blades. Wet cutting blades must be supplied water for cooling and to remove the slurry from around the blade. Inadequate water to the blade will cause segment loss, blade warpage, and blade failure. The water must cover the entire blade, from the mounting flanges to the cutting edge. A good rule of thumb is to direct the water correctly and use enough to cool the blade, wash the slurry from the cut, and leave a small edge of clear water at the outside edge of the slurry trail. Excessive water seldom helps and can slow down cutting production rates. On the other hand, never try to rig an unconventional water supply to cool a blade. Spraying water on the blade won't work. A steady stream of water must contact the blade on both sides near the blade flanges in such a way that the force of the stream and centrifugal force combine to move the water to the edge of the blade and into the cut. Inspect all blades before installation. Never use a damaged blade. If the blade is cracked, the core excessively worn, warped, or out of round, if segments are missing or the arbor hole is worn or damaged, the blade is unsafe to use. To install the blade, raise the saw high enough to allow clearance for mounting. Before starting the mounting procedure, make sure the ignition switch is off or the engine kill switch is in the stop position. Make sure all power sources are disconnected from the saw. Right side of saw has left-hand threads, and the left-hand side of the saw has right-hand threads. Remove the blade shaft nut or bolt and the outer collar or flange. Inspect both flanges and the arbor shaft for damage, nicks, and burrs. The inner flange should be tight on the shaft. For quick disconnect style blade shafts, inspect the blade shaft's internal threads to assure that they are free of debris and that the threads are not worn or damaged. Replace the blade shaft if thread damage is found. Inspect the blade shaft bolt threads for wear and replace if necessary. A good rule of thumb is to replace the blade shaft assembly if the blade shaft bolt has been replaced more than once. Check to make sure the inside and outside flanges are of the same diameter, not excessively worn, and free of concrete buildup on the clamping surfaces. ANSI regulations specify that the flanges must be at least 1/6 the diameter of the blade you will use. Use of undersized flanges can lead to serious injury. Slide the blade onto the arbor shaft oriented to the direction indicated on the blade. It should fit snugly. Do not force it, alter the arbor hole, or file the blade shaft to force a fit. If it does not fit, either there is damage or you have the wrong blade. Align the blade so the pin on the flange is through the drive pin hole on the blade and into the inner flange. Hand tighten the mounting nut or bolt with the pin in the hole. Prior to wrench tightening the blade shaft nut, grasp the outer edge of the blade and rotate it up toward the back of the saw to remove any clearance between the drive pin and the drive pin hole. Then tighten the blade shaft nut securely according to the manufacturer's instructions, using the proper wrench. For quick disconnect style blade shafts, to assure proper bolt torque, the operator should use a torque wrench and apply at least 95 foot-pound of torque. Please see the owner's manual to verify how much torque to apply. Before starting the saw, make sure the blade guard is installed properly and will not interfere with the blade. Again, never attempt to operate a saw without a blade guard. Because there are hundreds of types of flat saws and new models offered every year, it is impossible for this program to cover all operation details for every saw. That's why you must read and understand the operating manual for the saw you will be using. There are some standard pre-operation inspection, setup, and maintenance factors regardless of saw type. Before starting operation, check for missing or loose nuts and bolts, and check any drive belts. Tighten or replace them if necessary. On air-powered saws, always use a safety pin or wire on air hose connections. Do not turn the air on when the hoses are not connected or the saw on-off valve is in the on position. With hydraulic-powered saws, be sure the hoses are of sufficient size and strength to handle the pressures involved. Also, make sure hose connections are tight and the on-off valve is off before starting the power pack. When making connections to three-phase power sources for electric-powered saws, make sure the blade rotation is correct. Also, refer to the operations manual and observe all local, state, and federal electrical codes. Never allow connectors to come in contact with water. Check out saw controls to make sure they are operating smoothly and correctly. Check the water supply to the blade. Usually, a flow of 2 to 5 gallons per minute is needed to cool the blade. Before starting the saw, make sure the blade is raised high enough to clear the ground when it starts. Make sure the handlebars and other controls are locked in the correct position for operation. If the surface is not level, always saw up the incline, never downhill. The cut line should be properly marked. For example, a chalk line mark protected by a clear overspray, or a cut line marked with layout spray paint over a string line. Start the saw with the blade away from you, other personnel, and any tools or obstructions in the area. If using a pull start saw, have a good grip on it and good balance when you pull the starter cord. With self-propelled models, place the saw in neutral. On diesel saws with glow plugs, allow 5 to 15 seconds for the plugs to achieve full heat before engaging the starter. With all of these procedures checked out, start the saw the way the manual indicates it is to be started. The blade should come up to speed and run smoothly. When a blade in safe condition is properly mounted on a saw in safe condition, the blade will run without wobble or vibration. It will be solidly mounted, balanced, and true. Wobble and vibration are indicators of unsafe conditions. Now, we'll demonstrate making a cut using a self-propelled walk-behind type saw. Make sure that the saw shaft speed matches the blade RPM recommendations for the blade in use, as all operations are performed with the engine at full throttle, except when using large diameter blades, which may require lower engine RPMs. Align the blade on your pre-marked cutting line. Turn the water on and recheck that there is sufficient water flow to both sides of the blade. If water flow is ever interrupted, stop cutting immediately. Adjust the cutting depth indicator. It will read 0 as the blade just touches the surface. Set your depth stop 1/4 to 1/2 inch deeper than the desired depth of cut to allow for some riding up as the blade moves along. Lower the blade to the desired depth. It should cut into the material, not burn its way in. The speed that the blade lowers can be adjusted by turning a hydraulic flow control valve located under the cowl near the hydraulic pump assembly. If there is smoke or fire at the point of contact, either you have a water supply problem, the blade is too hard for the material, or you are feeding the blade in too fast. Slowly push the speed control lever forward until the blade starts to ride up in the cut. Then decrease the speed about 10%. This is the maximum cutting speed for this blade in this particular material. Maintain a steady, even forward speed. Avoid twisting the blade in the cut. A spray of cooling water off the front of the blade to one side is an indication you are skewing the blade in the cut. Excessive pressure or speed will cause the blade to ride out of the cut and reduces blade life. It can knock the core out of tension or knock segments off the blade, especially if reinforcing steel is encountered. Also, it creates excessive heat that glazes the segments and damages or pulls the diamonds from the matrix. While the blade is in the cut, don't let it spin without cutting. This increases wear on the bond and causes diamonds to discharge before their cutting life is over. If you're going to stop cutting more than momentarily, remove the blade from the cut. As long as the blade is cutting smoothly and freely, you are getting the most from your equipment. Forcing the blade into the cut will only slip the belts or stall the saw. If the blade binds or stalls in the cut and stops the motor, raise the blade out of the cut. Disable the engine, motor, or power pack for safety, as at any time when you would handle or work on the blade or mechanism. Remove or open the blade guard and inspect the blade for damage. Retighten or replace the blade as required. Information on other problems encountered while cutting is contained in the video unit on troubleshooting. There are special considerations to any cutting job. As a true professional, you'll want to know exactly what the customer expects. You will know the specifications and the capabilities of your saw. And you will take time to find out everything you can about the cutting situation and the material you'll be cutting. For example, does the surface incline in such a way that it will cause undercutting on one side of the blade? If the surface is asphalt, is it underlaid with concrete? What is in or under the slab? Are there electrical, water, or gas lines that must be disconnected or turned off? Is there reinforcing wire or steel? If so, what kind? If you encounter reinforcing steel, you may have to slow your forward speed or backcut the steel. Experience is the best teacher as to which method works best in what condition. When cutting pavement on a grade, adjust the cutting depth so the blade does not cut into the sub-base. Otherwise, abrasive material from the sub-base will grind against the blade, resulting in segment undercutting. Segments will likely be lost and the blade ruined. If the surface slopes to the left or right of the saw line, this will tend to put more pressure on the downhill side of the blade. This will also result in excessive side wear, undercutting, and shortened blade life. Use leveling planks if possible. If not, reverse the blade frequently to equalize the undercutting effect that would otherwise affect only one side. When making more than one pass, always cut in the same direction, especially on uneven or unlevel slabs. Turning around and cutting back to your starting point can cause excessive side pressure on the blade. As mentioned, always find out whether there are utilities in or under the slab, and if so, make sure they are shut off. If slab depth is unknown, there are 3 methods to determine the thickness. First, watch for a change in slurry color. The color will change from grayish brown or tan to dark brown as the blade begins to pick up dirt. Second, use the blade as a depth indicator. Insert the blade into the cut. If the blade hits a soft bottom, you are through the slab. Finally, saw a 3-sided wedge to determine the thickness. The obvious concern when sawing through suspended slabs, such as bridge decks and upper-level building floors, is preventing the sawed-out section from falling and causing damage, injury, or death. An associated principle is that when the final cut is made, you and the saw must be on stable, uncut footing. All suspended slabs are reinforced with rebar, cable, or a steel pan, and overcutting or core drilling at the corners will be necessary in order to remove them. On the other hand, don't assume more stability than you can be sure of. Never cut across an expansion joint, assuming the slab will support you or the saw. Some precast slabs are hollow. Never assume that you can cut 3 sides of the opening and trust the 4th, the uncut side, to support anything. Before making that last cut, always make sure the cutout section is properly rigged or supported for removal. If a crane is being used to remove the cut section, never rely on expansion anchors to hold a piece, unless a lifting plate and more than 2 anchors rated at double the pull-out capacity are properly fastened to the slab. Here is a safe rigging. 2 holes equally divide the weight of the piece. A steel choker cable and direct pull cable will work, or lifting eyes rated for the slab weight and cable slings with a lifting device that will handle twice the weight of the piece. The lifting rig should be attached and under tension when the last cut is made. If the slab is shored from below, it is your responsibility to know that the shoring will support the weight of the cut slabs. Also, you must make sure the saw does not cut the shoring.